Good morning, this is your Stat Sensei, Mr. Spensei, and this is an assignment on two sample T confidence interval, and it's going to be scenario for education pay. I have to say that the conditions for this are in the previous video, so if you want to see the conditions, you have to watch the previous video. So a sociologist is investigating the relationship between education level and income. The hypothesis is that the individuals with higher education levels, such as a bachelor's degree, earn more. So we said, hey, higher education is greater than a high school diploma as far as income. The sample consisted of 100 randomly selected individuals. So we had a sample size of 100 with bachelor's degrees. So this is our bachelor's degrees with 100, and that's what we have here. And then we said we also had 100 randomly selected individuals whose highest education was a high school diploma, which is what we have right here. And so there's our samples, 100 and 100. We said the mean income for the bachelor's degree was 57,000, and it had a standard deviation of 8,000, and we included that here. Then the next thing we wrote down was the high school diploma had an on average, a sample average of 35,000 with a standard deviation of 6,500. Okay, and then we had more than 5 million adults have bachelor's degrees. That's our population for bachelor's degrees, and 10 million adults with a high school diploma. So that was our population for the high school diploma. When we went to draw our graph, we have to remember that confidence intervals are centered on the sample, and in this case are centered on x1 minus x2, or x bar 1 minus x bar 2, which in this case 57,000 minus, not times, but minus the 35,000. So it would be centered on 22,000, because what we're trying to estimate is the actual difference in income. So x bar 1 minus x bar 2 is 22,000, and we're looking for 95% with a lower bound and a upper bound. Okay? All right. Although it seems a little bit weird, this is the best time to go ahead and run the interval, because we're going to need some information from that interval. So we're going to use our calculator and get that information. And I can move that. So stat test T interval, which is like number 0. And we have statistics, so stats needs to be highlighted. X1 is 57,000. S1 is 8,000. And our sample size was 100. Then we have X2 is 35,000. Sample size of 6,500. N of 100. And they said they wanted a 95% confidence interval. And we never pool in this class. All right, so we ended up getting 19,967 to 24,033. And we know that the mean x bar 1, x bar 2 is centered on that. So there's our lower bound. Oops. There's our lower bound, and that's our upper bound. All right, one of the things that we need desperately from that is our degrees of freedom, which is 190.03, because we're going to need that to calculate T star. So we need to go ahead and write that down. So I'm going to write that down here. Not that this is the best place for it, but since that's where we are, we'll copy it here. 190.03. There's a very complex formula for that, but we don't have to know it for this class. Okay, so here's our formula. X bar 1, so sample mean 1, we have that. Sample mean 2, we have that. We don't have T star, so we're about to have to calculate that. But we do have the sample standard deviation for the first one. We have the sample size for the first sample for the bachelor's. We have the sample size for the high school diplomas, and we have the sample size for high school diplomas. So we have everything we need, except we need to go calculate T star. Well, we calculate T star the way we always have. We're going to go to inverse T. So second vars, inverse T, parenthesis, 1 minus 0.95, close parenthesis, divide by 2. And we need that degrees of freedom, 190.3. And that's all I have. Inverse T, 1 minus 0.95 divided by 2, degrees of freedom, 190.3. Excuse me, 190.03. That would actually make a little bit of a difference. And we get 19725. All right, so our T star is 1.9725. You can see I have a negative, but you always want to make it positive like we have here. Make sure you choose the positive. At that point, you have everything you need to plug into the formula. So 57,000 for the X bar 1 for the bachelor's, the 35,000 for the sample mean for the high school diploma. Then we're going to square the standard deviation of the bachelor's and divide it by its sample size. And that's what we have here, 8,000 squared divided by 100. We also have the 6,500 squared, that's that sample. So, I mean, that's standard deviation squared for the high school diplomas, and then we divide it by its sample size. These numbers may not be the same. They just happen to be that N1 and N2 are the same in this case. Please remember, T star is what we just previously calculated, excuse me, right here. All right. This was the degrees of freedom that I highlighted, but this right here is our T star, and we plug that in right there. All right. If you remember where we went on the calculator, we went stat test to number 0, and it says 2-sample T interval. Guess what? 2-sample T interval. That's what we need to write down. All right. Okay. When we go to define parameters, we're going to have 2 parameters this time. And the reason we're having 2 parameters is because we're using 2 samples. So we know what X bar 1 is. We know what X bar 2 is, but we're trying to estimate mu1 and mu2. So we're trying to estimate the sample mean for the bachelors, how much they earn, the bachelors earn. And we're also trying to estimate the population mean for the bachelors and the population mean for the high school students. So that mu1 equals the true population mean income for bachelor degrees. That mu2 equals the true population mean income for those with only high school diplomas. Okay? All right. The conditions, we did those on the previous page. In the warm-up, there they are. I'm not going to go through them again, but there, if you want to catch a quick snapshot of them, there they are. So we have this difference. All right. And we notice 0 is not contained. So because 0 is not contained, it's clear that those with college degrees earn more money. And it looks like they earn somewhere between almost 20,000 a year to 24,000 a year more. All right. So what are we? Well, we are 95% confident the true population difference. This is really important. You need to have difference of the means. All right. That's super important for a 2-sample T. You won't have it for a hypothesis test, but for a CI, for a confidence interval, you need this. Income for bachelor degrees holder minus the income. You always have to say the order. Minus the income of high school diploma holders lies within our interval 1967 to $24,033. Now, please keep in mind, this part came from our lower and upper bound. And true population mean income for bachelor degrees holder, that was our first parameter. And then the income for high school diploma was our second parameter. So make sure you always have that, and make sure you have a minus. Make sure you include that minus for, hey, because we subtracted. And how do you know you subtracted? Well, didn't we go x1 minus x2 right here? And then also again right there. So we're estimating our best single estimate is 22,000, but it could be as low as 20,000 or as high as 24,000. All right. In repeated sampling, we expect this method to capture the true population. Once again, you have for confidence intervals, you have to include the difference of the means in income for bachelor degrees holder minus, once again, the minus we just talked about, the income of high school diploma holders 95% of the time. Well, this was the confidence level we used right here. So we used that earlier. That's what they asked for. And as we said before, this is the definition of parameter one, and this is the definition of parameter two. All righty. I appreciate you watching. I look forward to seeing you on the next one. Thank you.